So here are the notes for section 3.5. This is with equation solving and modeling. So here we've got how to solve exponential equations. So we've actually used this rule before. So if b to the u is equal to b to the v, then the two exponents must be equal, assuming you have the same base. For the logarithm, the same thing is true. Log base b of u is equal to log base b of v. Then u and v are to equal, because they're technically operations. So if you're doing the same operation on two numbers and you get the same thing, the numbers originally had to be the same. So here is algebraically how it solves. The first thing that we need to do is isolate our exponential part. So for this problem, I would need to divide both sides by 20 first. So this would become 1/2 to the x over 3 equals 1/4. So I need to write 1/4 as a power of 1/2. So it's the same thing as 1/2 squared. So since my bases are the same, that means I know that my exponents must also be equal. So x has to be 6. If you plug 6 in, you should get the same answer. So I plug 6 in, this becomes 6 divided by 3 is 2, 1/2 squared is 1/4, 20 times 1/4 is 5. Okay, so here I've got e to the x minus e to the negative x all over 2 is equal to 5. So we'll do e to the x. So I'm going to multiply the 2 across. Gives me this. Now this one has a bit of a trick, because this guy, since it has a negative exponent, is 1 over e to the x. So it'll look like this. So I need to eliminate the denominator of my fraction by multiplying everybody by e to the x. So this becomes e to the x squared minus 1 equals 10 e to the x. Now this, even though it doesn't look like it, is related to a quadratic. So I'm going to put everything on one side. So e to the x squared minus 10 e to the x minus 1 equals 0. So what I'm actually going to do is I'm going to make a substitution. I'm going to say that u is equal to e to the x. And that makes this equation become u squared minus 10u minus 1 equals 0. And then I can work out the quadratic. So negative b plus or minus the square root of b squared minus 4ac. So that's going to be minus 40 all over 2a is 2. So 10, so u is equal to square root of 60 over 2. Let me check my work. 4 times 10 squared minus 4 times 1 times negative 1. Oops. Oh yeah, I don't know what I'm doing. That's definitely wrong. I multiply by the b value. This should be plus 4, which means this is 104. Okay, so u is equal to 10 plus or minus, so 104 is 2 and 26, or is 4 and 26, so that's going to be 2 root 26 all over 2. So u is equal to 5 plus or minus the square root of 26. Now the problem is I don't want u, I want x, so I have to undo my substitution. And now what I can actually do is I might cheat and use something before. So if I want to cancel a natural log or an e out, I can take the natural log of both sides. Because what happens is this x comes out front and then those cancel. So x equals the natural log of 5 plus or minus the square root of 26. And that would be my solution. Not very nice, but solvable. Okay, so logarithmic equations. So solve log x2 equals 2. So the first step is, oops, sorry, wrong thing. So if I want to get rid of a log, I use the base, and these numbers become exponents on the base. So it's that's the common log. Everything becomes exponents on 10. So we're here, those cancel. That leaves me x squared equals 10 squared. So x is equal to 10. Technically negative 10 will work as well. The other way to think about it is the base is 10, the number to the right is 8. So you can get there just the same way. So these two things are equal, so you'd end up there. 100 equals x squared, so x is equal to plus or minus 10. Okay, before we can eliminate logs, we need to have all of them grouped together. So these two logs are separated with a plus sign, which means I can combine them into a single logarithm by multiplying the stuff after them. Over here on the right, that 2 is actually an exponent, so this statement is true. So since I have a single log on both sides, I can now cancel. So in order to solve this, I need to FOIL over here. So 3x squared minus 3x minus 2x plus 2 is equal to x squared. Now I've got x squared, so this is quadratic, so everybody comes to one side. So this would be my equation. And then I would need to either quadratic formula or try to factor. So we'll just do the quadratic. So 5 plus or minus the square root of b squared minus 4ac, so 4 times 2 times 2, so minus 16, all over 2a, which is 4. So this is 5 plus or minus the square root of 9 over 4. So this is 5 plus or minus 3 over 4. So x is either 5 plus 3, which is 8 divided by 4, or 2, 5 minus 3, which is 2 divided by 4, which is a half. Now, we do have to check our answers because we're not allowed to take logs of negative numbers. So if I use x is equal to 2, that gives me 6 minus 4, so that's positive, it's okay. 2 minus 1 is positive, it's okay. 2 here is also okay, so 2 works. If I plug a half in, 3 halves minus 2, so 1.5 minus 2 gives me a negative number. So 1/2 actually isn't a solution, only 2 is. Okay, so order of magnitude. So the common logarithm of a positive quantity is referred to as order of magnitude. So 100 has an order of magnitude of 2. It's 2 powers of 10. 1,000 is 3, 10,000 is 4, 1,000,000 is 6, things like that. So how many times more severe was the 2001 earthquake in India than the 1999 earthquake in Greece? So we need to find the difference first. So 7.9 minus 5.9, so that's 2. So, but this is an order, Richter scales are measured in orders of magnitude, so this is actually 10 squared. So it is 100 times more powerful. Each increase on the Richter scale makes the earthquake 10 times stronger. So going from 6 to 7, the 7 earthquake is 10 times stronger than the 6. Going from 6 to 8, the 8 is 100 times. 6 to 9, the 9 is 1,000 times stronger. So it's not just 1 or 2 or 3 more. The other place logarithms is used is in pH. So for chemistry, the pH of a solution is equal to the negative log of the hydrogen ion concentration. So some, especially sour vinegar, has a pH of 2.4. A box of leg and sickle baking soda has a pH of 8.4. What are their hydrogen ion concentrations? So for the vinegar, we know that the pH is 2.4, and that's equal to the negative log of the concentration. So I need to divide the negative sign across, so 2.4, negative 2.4 equals x. Here at the log, everybody becomes exponents on the 10. So 10 to the negative 2.4 is equal to x. So 10 to the negative 2.4 is 0.00398 mole. Or not mole, capital M, molarity. Okay, and then for the baking soda, similar process. So the pH is 8.4 equals the negative log of the pH. So negative 8.4 equals the positive log. Everybody becomes powers on 10. So 10 to the negative 8.4 is equal to x. So x is equal to 0.1, 2, 3, 4, 5, 6, 7, 8, 4. So very, very low. So typically, since pH is the negative log, the higher the hydrogen ion concentration is, the less it becomes. So how many times greater is the hydrogen ion concentration of the vinegar than the baking soda? So we find the difference. So 8.4 minus 2.4, that's 6, so it's 10 to the 6th, or 1, 2, 3, 4, 5, 6. So what is that? 1,000,000 times larger. If you can actually work that out, if you divided this number by that number, 0.004 divided by 0.123456784, you'll get the same number. How many orders of magnitude? That's actually that number right there by 6 orders of magnitude. Okay, we also have this formula called Newton's law of cooling. So as object that has been heated will cool to the temperature of the medium, so the surrounding essentially when it's placed, such as the air or the water. The temperature T of an object at time, little t, can be modeled by this equation for an appropriate value of K, where Tm is the temperature of the median, so like the surrounding temperature. T0 is the initial temperature of the object, and we'll have to figure out what K is. Okay, so for example 7, a hard-boiled egg at temperature 98 degrees, so that is my T0, is placed in 16-degree water to cool, that's Tm. 4 minutes later, so that is little t. The temperature of the egg is 45 degrees. Okay, so we actually have to cycle through this problem twice because we need to figure out what K is first, and then use that to finish the problem. So we know that 4 minutes later, so that's a T value. So 45 degrees is equal to, so it's Tm, so that's 16, should have plus T0, which is 98, minus Tm, so minus 16, all times e to the negative kt. So negative k, and our time is 4. So I can clean this up. So 45 equals 16 plus, so 98 minus 16 is 82, e to the negative 4k. So that's my equation. So I need to solve for k. So bring the 16 across. 45 minus 16, so this is 29 equals 82 e to the negative 4k. Divide both sides by 82. So 29 80-seconds equals e to the negative 4k. So to get rid of the e, I need to take the natural log of both sides. The natural log of 29 over 82, the e is going to cancel, is equal to negative 4k. So k is equal to the natural log of 29 over 82 all over negative 4, which has a decimal. So 29 divided by 82, natural log of that, divided by negative 4. So k is about 0.26. Now, to actually finish the problem, when is the egg 20 degrees? So I want my final temperature to be 20. Medium is still 16, still starts at 98, and then e to the negative 0.26 t, because I'm solving for the time. So the steps are actually almost identical. They're actually, in fact, identical, so we're going to end up with t instead. So bring the 16 across, so 4, and then we can combine like terms. 82, e to the negative 0.26 t. So divide the 82 across, 4 divided by 82 is 2 over 41, e to the negative 0.26 t. Take the natural log of both sides to get rid of the e. And then divide everybody by that decimal. So ln 2 over negative 0.26 is equal to t. So t is about, so the natural log of that is that, divided by negative 0.26 is that, so t is equal to 11.6 minutes. So 11.6 minutes after you drop it in, it'll have cooled down to 20 degrees, which brings us to the end of this section.